நானே வந்து அந்த தேவால 5 பேர் வர்றாங்கன்னு சொன்னா இந்த அம்மாவை போட்டு 8 பேருக்கு டிக்கெட் போட்டுருந்தாங்க. 6 2 வந்துரும் மேடம். அதெல்லாம் வந்துரும். 20 நாள் இருக்குல்ல. பாலகுமார் என்னன்னாரு, அவ்வளவுதான் மேடம். எனக்கு அதெல்லாம் சொல்றீங்க பாருங்க. முத நாள் வரைக்குமே பண்ணலாம். என்ன போக்குறது? முத நாள் வரைக்குமே பிளேட் டிக்கெட் போடலாம். யார் என்ன சொல்லுங்க? காசு கொடுத்தா டிக்கெட் தரப்போ. மேடம் ஈவெண்ட்டை பொறுத்த வரைக்கும் பாருங்க, அஜெண்டா உள்ள போனா டிஸ்பிளேல பேனர், 3 வந்து எம்சி டெஸ்க், கொடுக்கறதுக்கு ஷால்வு, கையில கொடுக்கறதுக்கு அவார்டு, பேப்பர் ப்ரெசென்டரோட லிஸ்ட் ப்ரெசென்ட் பண்ண போறாங்க. மிதுன் கிட்ட வந்து டீ அரேஞ்ச் பண்ண சொன்னாங்க. போன தடவை டீ பிஸ்கட் எதுவுமே வைக்கவே இல்லை. 3.5 மணி நேரம் டீ பிஸ்கட் வச்சாங்களா? வச்சாங்க. மிதுன் டீ பிஸ்கட் அரேஞ்ச் பண்ணாங்கன்னு சொன்னாங்க. அந்த பிரேக் ஹவுஸ் நான் 10 மணிக்கு உள்ள போறோம்ல, மதியம் 1 மணிக்கு தான் முடிஞ்சு வரும். டீ பிஸ்கட் அரேஞ்ச் பண்ண சொன்னாங்க.
சொல்லுங்க.
எங்க கல்வி
மேம் சொல்லுங்க. ஆமாம் ஆமாம், பார்த்தேன் பார்த்தேன், நல்லாவே இல்லை. என்ன பண்ணுறது? பேசாமல் 2 ஃபோட்டோ வேணாம், ஃபோட்டோ மட்டும் இந்த மாதிரி வச்சு பேக்ரவுண்ட் வேறு தான், நல்ல பேக்ரவுண்ட். சரி பாருங்க. இதான் அந்த அதான் அவங்க கிட்ட சொல்லி அவன் ஃபோட்டோ மட்டும் வச்சுக்கலாம். சரி அப்புறம் பேசுகிறேன்.
Good evening, sir.
Good evening, madam.
Yeah. Shall we start, sir?
Yes, ma'am.
Subha?
Yes, ma'am.
Okay, start, ma.
Good evening to another person here. On behalf of VISTAS, I take immense pleasure in welcoming you all. I have briefly focused on edge and fog computing for IoT-driven research. This initiative is part of our continuous efforts to empower educators and enhance the quality of teaching, learning, and research. I would like to invite Dr.K.Kasturi, Associate Professor, DAC, to deliver the welcome address.
Yes, ma'am. Yes, good evening to all present here. On behalf of Wales Institute of Science, Technology and Advanced Studies VISTAS, I take great pleasure in welcoming you all to the day 3 of our 5 days faculty development program on innovative tools and methods in emerging technology-driven research. We are privileged to have with us today our esteemed resource person, Dr. Konda Krishna, Associate Professor, Department of Computer Science and Engineering, School of Computing, Mohan Babu University, Tirupati, Andhra Pradesh. His expertise and experience in the field of edge and fog computing for IoT-driven research will surely enrich our understanding and inspire new perspectives. I also extend a warm welcome to our respected faculty members, participants, and organizers who have joined us this evening. Your active participation is what makes this program meaningful and successful. We look forward to an engaging and insightful session ahead, sir. Once again, I welcome you all and wish the session a great success. Sir, the session is done.
Thank you, ma'am, for this warm and inspiring welcome. I would like to invite Dr.S.Jayashree, Assistant Professor, to introduce our chief guest to the audience.
It is my privilege actively
Jayashree ma'am, the audio is not clear.
now, ma'am.
Yes.
Hello. Okay. And is actively engaged in academic research and administration. A life member of several professional bodies, including IE, ISTE, and CSI, and so on. He has published patent, textbook, and numerous research papers in reputed journals. His research interested including wireless sensor network, IoT, network security, and emerging technologies. Dr. Krishna has served on editorial and technical committees for various conferences and has been honored with multiple awards for academic and research excellence from 2022 to 24. So I welcome you, sir.
Thank you, madam.
I vote to the section. I vote to section to you, sir.
Thank you, madam.
Thank you. Sir.
Good morning to everyone.
Good morning, sir. Good morning, sir.
Ma'am, my sharing is visible to everyone?
Yes, sir.
Okay, madam. Thank you. Once again, good evening to everyone. In today's session, I have discussed about the edge and fog computing for IoT-driven research. What is the main role and their importance in IoT devices, using of the purpose like different smart agriculture and urban planning and healthcare like. What is meant by edge and fog computing? It is a processing the real data and insights in the IoT systems. In today's session, I have to cover these topics: introduction about the edge and fog computing in IoT purpose, and need for the edge and fog computing in IoT devices, and what are the main architecture and their role in the IoT devices, and edge AI and tiny ML algorithms and use cases, and their deployment strategies and future trends and conclusion. Now I'm going to the session. What is meant by introduction about the edge and fog computing? What is the main definition of the edge computing? Edge computing means it is a near close to the source, like example like sensors and devices. It transferring the data from the one node to another node to the near to the cloud edge. That is called the edge computing. Now coming to the fog computing. And fog computing means it extending the cloud capabilities closer to the based upon the edge data processing. That is called as a fog computing. It mainly using for the distributed computing and intelligent systems and etc. The main purpose we are using for the edge and fog computing in IoT drivens, mainly it can be useful for the reducing the latency, bandwidth usage, and improve the responsiveness of the data between the one server to another server or in between the one device to another device. This is the understanding concept about the edge computing and fog computing. For understanding about the IoT means it can optimizing the IoT in data processing. It can root processing and optimizing the data between the one node to another node and one server to another server, or one network to another network. Using by the edge and fog computing, we can reduce the latency and responsiveness of the between the devices and etc. In edge computing, processing data in between nearly the data sources such as sensors and local devices and microservers, etc. It can minimizing the distance between the nodes and data traveling between the nodes and enabling the low latency and immediate decision making. For processing the real-time data analytics, based upon the data analysis, you can immediate take in the data responsiveness, and based upon that responsiveness, you can immediately predict the decision making between the data and devices. And comparing to the fog computing, it can extending about the or cloud storage and edge computing capabilities to the edge of the computer network or any communication network or any social network, etc. Here the fog nodes act as an intermediate between the layers and the central cloud and providing the distributed storage, computation, and network services. And these are the distributed approaches relevant for the IoT and which generates the massive volumes of the real-time data from the countless devices, demanding efficient and responsiveness processing. This is the understanding concept about the IoT purpose. Edge computing means the near to the data sources and it can transform in between the one node to another node. Fog computing means it based upon the edge computing and extending their capabilities to the edge of the network. What is the need or importance of edge and fog computing in the IoT driven research? In IoT, mainly without using by the edge and fog computing, it can facing the so many challenges or problems like the high latency problem, that means distance between the nodes and bandwidth bottlenecks and transforming the data speed and their security and their data transmission between the nodes. Without using by the edge and fog computing, we are facing these are type of the problems in the IoT driven research applications. We have to cover and addressing these issues. We can use the edge and fog computing in the IoT driven real-time applications very efficiently and effectively to addressing by the challenges like real-time insights, real-time data analytics, and supporting the autonomous support systems and smart cities and etc. and using by the drones and robots and reducing the dependency on centralized cloud infrastructure, etc. What do you mean by the high latency? Here the cloud systems introduce the delays, implementing the real-time applications. Data traveling between the one node to another node in a slow motion. It can covering by the edge and fog computing. And we have the faster response given by the edge computing and using by the fog computing applications. And bandwidth bottlenecks. Massive data transfer to the cloud strains network resources. It can store the large volume of data and store the large volume of the data, etc. sources, etc. And main purpose is the providing the very, very effective and security and privacy. And this is the architecture for the edge computing. This is the example architecture using by the different AI technologies, different IoT devices and IoT routers and end users and their applications. Edge computing means it is close to the very source devices. What are the devices is providing the data? It is very close to the using by the AI technology and very close to the data resources generation. This is the architecture of example architecture of a edge computing establishment in the IoT devices. Here mainly focusing on the data generating sources and their applications like instances, responses, and continuous operation even in the absence of cloud connectivity. Without using the cloud connectivity also, you can transfer the data and given the faster response and based upon the responses, you can predict the faster decision making and etc. This is the real-time example or application using by the edge computing Without the cloud connectivity, smart traffic lights equipped with the edge computations, etc., there was optimizing the and data flowing and preventing the congestion and without sending the video data to a remote server, etc. It is the one of the real-time application without using by the cloud connectivity, using to the edge, you can using by the smart traffic lights and etc. What are the main components and characteristics of the edge computing architecture? The main components in the edge computing is the IoT devices and device 1 and device 2 and device 3, and these are the IoT and sensors and etc., and using by the edge nodes and using by the cloud and etc. These are the main components in the edge computing architecture: devices and sensors and edge nodes and cloud and etc. The main characteristics of the edge computing architecture is the low latency and processing of the data very fast and secure, and providing the data privacy and given the faster responses. Based upon the responses, it can predict the faster making decisions and for processing of the data and for the data transmission and etc. It can also work in the offline without using the cloud connectivity. Also, we can using the edge computing architecture in the IoT devices. That is the main purpose and usage of the edge computing architecture in the IoT driven researches. This is the fog computing architecture in the IoT driven researches. In fog computing means it is an extend to the cloud to the network edge, and it is acting like a intermediate between the different levels and processing the data between the different devices and different levels of the nodes and cloud layers. It containing by the different layers and IoT device layers. It can transform the data from the sensors to actuators. That is the IoT device layers purpose. And the cloud layer purpose, it can store the long-term storage and deep learning purpose, global analytics purpose, and overreaching the system management and etc. It can act as an intermediate between the IoT and the fog nodes. These are the cloud layers, and these are the IoT device layers, and it is an intermediate between the fog and the IoT layers. And coming to the third one layer, fog nodes. Based upon the fog nodes, it can providing and processing the data aggregation and pre-processing purpose and distributed analytics purpose and various across the multiple edge devices. These are the layers in the fog computing architecture. It is a very close to the edge network, and it extending the cloud capabilities to providing the IoT driven research applications. Very simple and secure data network transfer between the different layers. The main function is it is enabling the distributed analytics, data catching, and rapid response for the cluster of the devices, and it can reduce the load on the cloud, improve the data security by localizing the data, and it can improve the efficiency and effectiveness of the IoT systems, etc. Using by the fog computing, you can providing the long-term distances and storing the large volume of the data and processing of the data analytics and different intelligent systems using by the smart agriculture or healthcare applications. It is very, very useful and effective in the latest research IoT devices and applications using by the fog computing architecture. Now coming to the edge AI and the tiny ML methods using by the intelligent and smart. And previously we discussed about the edge and fog computing without using by the any AI technology. Now in the tiny ML means you can use the smart AI workness using by the IoT devices. It bringing the AI into the directly edge devices and ultra low power microcontrollers revolutionize the real-time decision making and resource efficiency in IoT. Smart utilization of the data resources and their devices and data processing, etc. Introducing by the edge AI with the tiny ML methods. What is meant by edge AI? Edge enabling the models to be run locally on devices, allowing the instances inferencing between the one layer to another layer and one device to another device. That is called as the inference decision making, and without constant cloud connectivity. Without using the cloud servers and their networks, you can processing the data very efficiently and effectively using by the smart AI. Critical applications like the real-time anomaly detection and predictive maintenance, and in the weather forecasting and sales marketing and stock marketing prices, we are using by the Edge AI with the tiny ML methods. What is meant by TinyML? It is a specialized field of machine learning focused on shrinking AI models to fit onto the resources, constrained, low power microcontrollers, etc. Tiny means in a small devices and small and low level of devices, it can process the very data effectively and predicting the decisions very efficiently and accurately using by the TinyML methods. The main benefits is the energy usage and reduce the need to the data controllers and data privacy without using by the cloud and etc. And mainly real-time applications are the smart agriculture and smart healthcare. These are the examples for the tiny ML methods using by the edge and fog computing transforming into the smart AI with the smart agricultures. Provide the immediate and actionable insights leading to the more sustainable and efficient farming practices, introducing about the our edge and fog computing with the smart AI technologies. This is the solution for the fog computing. Farm-based microservers aggregate data between the one node to another node. That means soil moisture levels and water prediction levels, irrigation level in the water levels, what are the crop prediction and etc. These are the benefits using by the smart agriculture. Water optimization, that means real-time soil moisture data and reduces the pesticide usage at the what time and at the what level we can and give the and pesticide usage in the farming, agriculture, etc. And faster responses, and you can get the immediate alerts using by the smartphones and the using by the email alerts and etc. And predictive analytics, it can very effective to the crop rotation and the resource planning. Based upon the nature and based upon the season, we can predict the crops and their seasonal crop products and etc. And second real-time application is the enhancing the healthcare with the distributed intelligence using by the tiny methods. It is the main problem for the healthcare conditions. The real-time monitoring and patient monitoring is the very difficult level nowadays for saving of the human lives. Based upon that, it can very helpful and effective to give the real-time data analytics and real-time monitoring of the patient diseases and etc. Critical health events, and they're given the faster responses and very patient monitoring and etc. This is the problem, the need for continuous and unobstructed patient monitoring with minimal delays. The minimal delay processing of the data between also it can cost the human life and endanger the human life at very risk. This is the solution for the healthcare problem. We can wearable devices. In nowadays, so many people are using by the smart watches and smartphones and everything in home sensors, in smart devices operating by the smartly and predicting the our BP levels, sugar levels, and predicting the and any disease predictions and everything. Example, the heart rate, oxygen levels, and temperature, etc. This is the main advantage for the edge computing using by the tiny ML methods. These are the general use case for the smart agriculture. What is the problem here and what is the edge solution? What is the fog solution? To recover the and using by the smartness in the IoT devices and IoT driven research applications. The timely insights into the crop health are crucial for the farmers. The timely updations and seasonal products and what are the seasonal natures and crop diseases and plant diseases, identifying the moisture levels, water levels, and pesticide levels at what time and at the water level we can give the pesticides and etc. Using by the edge computing, sensors with tiny ml detect the soil moisture levels, pesticide levels, and diseases instantly and providing the fast data responses. Using by the fog computing, fog nodes are the aggregating the regional data for the predictive analytics and their border insights. There are the significant benefits: water optimization, reduced pesticide usage, faster responses to plant diseases, ultimately improving agriculture efficiency and sustainability. This is one of the main real-time IoT application for edge computing and fog computing using by the smart agriculture purpose. And second use case is the smart healthcare purpose. It is the main problem here. Continuous patient monitoring requires the immediate data processing and etc. If in data processing is delayed means it will cost the human life and very effectively. And what is the edge role here? In use cases, edge role is the wearable devices like continuous monitoring devices in the very near to the patient like IoT devices and CID devices and sensors and using by the tiny ML methods, it can give the accurate data time to time without time delay and based upon the data responses, you can immediately give the precautions and everything. This is the fog role. Fog nodes store the anonymized patient data for the hospital dashboards and reducing the network dependencies and etc. This solution provides the instant alerts for the abnormal heart rates, oxygen levels, ensuring the timely medical intervention and enhancing the patient safety and etc. This is one of the another real-time application for the using by the edge computing and fog computing and including by the IoT real-time applications using by the AI algorithms and tiny ML methods. Using by the edge computing, it can give the very accurate data and based upon the processing of the wearable devices. And using by the fog computing, it can give the reducing the network dependencies and hospitalized dashboards and anomalous data using by the fog role. This is the another use case for the smart urban planning or the smart urban cities and the smart villages. Now everyone converting into the offline to the online data processing and everywhere and in any cities or in villages and using by the individuals in home purposes in operating by the our ACs, machines and everything using by the our smartphone technologies like that. This is the one of the main in smart urban planning. We realize on the real-time monitoring of the traffic purpose and pollution purpose and energy usage purpose to create the more efficient and livable cities. In smart cities and smart villages and in the smart individual persons and smart homes and everything, the main role is the edge and fog computing. What is the main role of here edge? And IoT cameras and sensors detect the conjunctions or accidents instantly, etc. And this is the fog role used by the smart city management. The regional fog servers analyze their patterns for the smart city management, etc. And this integration enables the efficient traffic control using by the smart traffic control using by the AI and ML using by the IoT devices. Nowadays, in highways also, highway lanes also using by the sensors and IoT devices, they have to detect the our vehicle speed. And based upon that, we can controlling the vehicle speed and traffic controls and detecting the deviation in the traffic control and smart route navigations and smarter water irrigation departments and real-time environmental hazard alerts using by the sensing devices, and you can predict the earthquakes and their optimized energy usages and in the public infrastructures contributing to a truly smart urban environment. Nowadays, in IoT and using by the edge and fog computing and the smart AI technologies, everywhere in the using by the smart ways, operating in the individuals and home cities and villages in traffic lines, air pollution and water pollution, and detecting the earthquakes using by the sensing devices, sensors and IoT. There is a communication networks in between the social networks, and there is a smartly predicting the anything using by the fog and edge role only. This is possible to you can convert the smart agriculture and healthcare applications and urban planning, etc. How you can implement these are the smartness into the edge and fog computing and the IoT devices. These are the deployment strategies for the robust IoT solutions. What are the technologies, tools used to have to convert the offline to online or online to smartness, predicting the AI decisions and converting the smart traffic signals and converting the smart agriculture and converting the healthcare applications and smart cities, homes and individuals using by the hardware requirement. This is the main hardware requirement. What is the first one is the Raspberry Pi. It is a versatile for the prototyping and light edge tasks. Mainly Raspberry Pi useful for the small devices and small units for the homes and individual persons and in our mobile phones and home cities and etc. That is the Raspberry Pi useful for it. Very useful hardware choice for implementing the IoT driven research applications. And second one hardware choice is the NVIDIA Jetson. It is a very powerful for the edge AI with the GPU accelerations. And one of the small and image classifications and healthcare purpose, that is the main useful is the hardware choice is the NVIDIA Jetson. Raspberry Pi only for the our smart homes and etc. And NVIDIA Jetson is the smart healthcare applications. You can choose the NVIDIA Jetson hardware devices. And Intel Movides and OpenVINO. It is optimized for the deep learning inference, etc. In deep learning and tiny ML methods, we can choose the Intel Movides and OpenVINO hardware device for the edge and fog computing to implement the IoT-driven research applications. And fourth choice is the ARM-based edge gateways. It is mainly designed for the robust industrial environments and protocol translations. For smart industry purposes, we can choose these hardware choices. There are the different hardware equipments and devices using for the different purposes. Smart home and healthcare and the deep learning, smart agriculture and smart industrial purposes. These are the best choosable devices to implement the IoT real-time applications. These are the software ecosystem to implement the software toolset. For the Edge AI framework, we can use the TensorFlow Lite application or tool, PyTalk mobile application, OpenVINO for the deploying optimized the AI models on edge devices. For the edge purpose, we can use the Edge AI frameworks. That means TensorFlow Lite application or the PyTalk mobile applications we can use it for the edge device purposes. And the fog platforms, we can choose this type of software tools. Cisco IOX, Azure IoT Edge, AWS Greenness provide the runtime environments and device management and application deployment for the fog nodes. These are the pre-open software source tools used for the fog platforms. They are the best platforms to implement the real-time applications in the IoT devices. They are the containerizations. Based upon the edge and fog computing, we can containerization of the fog nodes with the edge devices. Combining of the edge devices with the fog nodes. That means Docker and Kubernetes are essential for the packaging, deploying, and managing the applications. And combining of the different methods, based upon that, we can use the containerization software too. It mainly consisting the across devices, the edge and fog hardware, ensuring the scalability and portability. Combining by the edge framework and flag platforms, you can using by the containerization tool, that means Docker and Kubernetes. These are the essential software tools and technologies using for the edge computing and fog computing. And third one is the security and scalability. How you can provide the security and scalability in the edge computing and fog computing to implement the real-time applications using by the IoT devices with smartness of the AI and TinyML methods. On device encryption, you can provide in the encrypting data at the rest and the prevents the unauthorized access. Encryption and decryption using by the edge computing and the secure firmware updates, ensuring over the air updates are authenticated and encrypted prevent the malicious code injection. Using by the fog computing, it can provides the secure firmware updates. And they are the edge firewalls, and it can protecting the local networks from the external threats. Using by the edge computing and their firewalls, it can protecting the local network, that means social networks and our Facebooks and Instagram networks and communication networks, etc. And next one, identity and access management. Implementing the robust authentication for the devices and users across the distributed network and etc. This is the main purposes of the providing by the security and scalability of the fog computing and edge computing using in the IoT devices real-time applications. First one is the main security providing by the device encryption, that means data privacy and security, and secure firmware updates don't allow the unauthorized access and malicious code into the IoT devices. And edge firewalls, it can protecting the other networks threats and external threats, and identity access management. These are the main features or purpose providing by the edge and fog computing used in the IoT applications. These are the different deployment strategies for the IoT solutions using by the hardware devices and software systems and providing by the security and scalability issues in the IoT devices. And now coming to the future trends, and these are the using by the 5G and 6G integration, mainly providing by the ultra low latency and perfect complement to the edge and fog, enabling the seamless, and it can provide in the high speed data transfer between the devices and local computing nodes and other computational resources purposes. We can implement the future also 5G and 6G technologies. It can also helpful by the edge and fog computing. Not in a 4G, it can helpful to implement in the 5G and 6G and future technologies trends like IoTs like. And AI model compression. It can compression the tiny ML models and long ML models and other deep learning models and reinforcement models. It can work with the any deep neural network models also. It can compromising the techniques, and it can sophisticating the AI to run on even the most resource constrained edge devices. It can run on the any edge devices using by the any deep learning technique. That means compression of the different AI models, TNML models and long-term ML models and deep learning networks and reinforcement learning networks and any different ML methods also. Compromising, compression the different AI models. It is also future trends. And presently we are implementing the TinyML models and other different ML models. Now in future we can combining the different models to implement the edge and fog computing in IoT devices. And third one is the blockchain for the IoT security. Using by the blockchain technology, it can integrating or combining the different distributed computing technologies. That means decentralized the ledger technologies are being explored to enhance the data integrity, authentication, and secure device-to-device communication in the distributed IoT environments. It can combining and merging the blockchain with the IoT also, using by the edge computing and fog computing. And what is the roadhead? That means here edge and fog computing are not just buzzwords. They are the different tools and technologies using by the cloud server to implement in the IoT driven research real-time applications. There are critical enablers for the next generation of the IoT applications and research. There more future scope in the IoT applications using by the sensor networks, blockchain technologies, and AI technologies, and different ML methods and different deep learning methods, etc. There is a huge and large scope and implementing the different type of applications and real-time applications using by the fog computing and edge computing in the IoT and using by the different wireless sensor networks. There is a very crucial and important role using by these technologies. 5G or 6G integration, AI model compression, and blockchain for the IoT security. By bringing the computation closer to the sources. Edge computing, that means very close to the data generation purpose. And fog computing means very extending the cloud capabilities for faster responsiveness and implementing the other data resources, etc. Their promise is the smarter and faster and more secure decision making across the different diverse domains. Using by the edge and fog computing, you can implement these technologies in the different domains like IoT and combining with the wireless sensor networks and computer networks, social networks, communication networks, and using by the smart AI and using by the blockchain technology and etc. For implementing the smart cities to autonomous systems and different real-time applications like smart agriculture, smart healthcare, smart urban, smart environments, smart industrials, smart homes, and everything. That is the main important role in the edge computing and fog computing in the IoT-driven applications. Thank you, madam.
Thank you, sir. Any queries is there? Any queries? Kindly ask.
Thank you so much, sir. Now I invite Mrs.Arokyaselvi to propose the vote of thanks.
Good evening, everyone. Ma'am, am I audible?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Can you hear me, ma'am? Okay, ma'am. Good evening, everyone. First of all, I would like to thank our management for giving this good opportunity to conduct this 5-day FTP on behalf of our department, Applied Computing and Emerging Technologies. I thank our today's speaker, Dr. Konda Krishna, sir, for his excellent delivery and informative speech on edge and fog computing for IoT-driven research. Thank you so much, sir. Really, it was very informative, and we have captured a lot of knowledge about edge and fog computing. Really, it will be very useful for present research people, those who are doing their research in IoT domain. And I would like to thank our department HOD madam, organizing committee, and my beloved faculty members for your wonderful cooperation. Last but not least, I would like to thank our participants. Once again, I thank our today's chief guest, Dr. Konda Krishna, sir. Thank you so much, sir, for your wonderful presentation. It was very nice and clear-cut presentation, sir. Very nice presentation, sir. Thank you so much. Thank you, one and all.
Thank you for giving the opportunity, madam. Thank you.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you all for your active participation and enthusiasm. Kindly fill the feedback form posted in the chat box. Thank you all.